that is required by our Ansible model. And lastly, we also have implemented a simulation engine in order to predict and simulate the AQI levels by considering multiple type of thermodynamics, monsoon, washouts, and traffic cycles for the areas that we don't have the sensor data of.
Hello everyone, I am Mohammed Salah. So we get the data, but data is useless unless it drives action. So EcoGuard transforms monitoring into management. So some actionable integrations are first managing traffic. We can divert smog rather than just predicting or monitoring by rerouting the heavy traffic away from the highly polluted areas. So we can plan and reroute heavy traffic away from the hotspots.
Can you go to the app directly and then show some?
Highly interactive UI, and along with that we are using Plotly and Folium for creating very intuitive and monitoring the AQI data that is available into preventing the AQI levels from rising further. And for that we came up with the idea of EcoGuard, and it helps us to create a paradigm shift by actively changing how the cities interact with the available pollution data across three major pillars, which are: first is predictive intelligence. So as Ali said, that the current AQS model
our EcoGuard it forecasts AQI data up till 6 to 12 hours. It forecasts the air quality spikes and provides actionable advice to the user what they should actually do.
Load monitoring. Also, it gave a foundation to MOSFET-based load correction logic, which can be used in automation systems. Another paper was online detection of lithium-ion battery thermal runway using real-time temperature monitoring. In this, they have used a random forest and non-supervised learning because normally what happens is we find there used to be like threshold like for under 50 degree or under 50 non-linear load variation suitable for dynamic demand and estimation, as my mate said. There can be possibilities where not only from 0 to 10 we have to go with a steady acceleration. In between we need to apply a sudden brake, or there could be a sudden jerk due to which the voltage may rise or fall. So that non-linear variations were also being predicted. Drawbacks were they focus on grid level charging stations.
Predicted outcomes, and these outcomes will be given to our risk evaluation center. The risk evaluation has three kinds of ways. One is our local HMI method, where only the raw data will be sent for local debugging purposes, testing purposes, and development purposes. Next is our MongoDB dashboard. To sense the things continuously, our system is a closed loop, and yes, the cost estimation of this system is rupees 14,000. Which is 7,000 for testing module, and 7,000 is our main system. Our entire system can be done in 7,000, but in the initial stage, if we want to do testing, it will take one module which is going to cost us 7,000. That is our EM15 generator. And other than that, yes, this is our entire system, and thereby we can complete our AI-driven battery load and thermal stress monitoring and correction system. Thank you.
We have decided the following pipeline.